All right, please open your books to 3.2. We're going to talk about the remainder theorem today. We're going to talk about long division and synthetic division of polynomials, okay? So in this lesson, what we're doing is we're learning how to do this. You may have seen this before, but this may be brand new for most of you. Dividing a polynomial by another polynomial, and we're going to specifically divide by a binomial today. So you know how to divide by a monomial. That's no problem. Like if you had x squared, or let's say 2x squared plus 4x plus 2. If you divided by 2, that's no problem. That's a monomial. You can do that. That's, you know what I mean? You just go 2, 2, right? 4, 2, 2, 2. So this becomes x squared plus 2x plus 1. That's no problem. We've done that before. That's easy. But what is a little bit different is if we have a binomial here. So in order to get to this spot, what I want to do is I want to just focus on something that you've all done since grade 4 or 5 or whatever it's been, and I will just zoom in a little bit here so we can see this on the board just a little bit better. All right, so if we had the number 327 divided by 12, this is how you would do it long division that you learned before. And there's patterns in this long division that's going to help us with long dividing polynomials. So watch carefully. So 327 divided by 12. Well, does 12 go into 3? No. Does 12 go into 32? Yes. So you take 32 and you say, all right, what's 32 divided by 12? It's 2 with some left over. So one of the ways you could think about that is that way. Or you could say 12 times what gives me a number that is just less than 32. So 12 times 2, and you would put the 2 up here. And you would go 2 times 12 is 24. You would write the 24 down there. Now what you would do is you would subtract, right? You would subtract to get the next line. So 32 minus 24 is 8. You'd write the 8 down there. And the final step on this first cycle would be to bring down the next digit and write it beside the 8. Okay? So that's one complete cycle of long division, a 3-digit number divided by a 2-digit number. Okay, that's one complete cycle. Now, we do everything over again. So 12 into 87, or 12 times what, gives us a number that is equal to 87 or just less. And that would be 7. 12 times 7, and you put the 7 up there. And 12 times 7 is 84, and you write that underneath, okay? Then you do subtract, you get a 3. And there's no more numbers left. Now, you could put a decimal and add some zeros and keep going. But we're not going to do that, okay? We're not going to do that. What we're going to focus on is 327 divided by 12 gives us 27 whole units with 3, it's actually 3/12 left over. Or we have 27 remainder 3. That's what you would have done in elementary school. So your answer here is actually 27 remainder 3. Exactly what this really means is 27 plus a remainder of 3/12 left over. Okay? Or that's really what we have here when we divide these two. All right, so we're going to move over now to polynomial long division. And again, if you haven't seen this before, do you have a question? Question?
No.
Are you sure? You good? Okay. We're going to look at polynomial long division, and we're going to do a lot of the same stuff. Okay? So we are going to write the polynomial right here. So this question is actually x squared plus 7x plus 17 divided by x plus 3. That's what it might look like. And I've zoomed in, so my pen is really thick here. Let me just get back to it. Okay? So that's what we're doing. X squared plus 7x plus 17 divided by x plus 3. This is how we would actually show that. So I'll zoom in again so we can take a closer peek at this. All right, so again, the patterns are very similar. And so what I do is I take a look at this x plus 3, and I say, okay, I am going to multiply x by 3 to get something that's close to x squared plus 7x. All right? But simpler than that, just take this x and take this first term. And that's how you're going to find out what you need to multiply by. So example, x times what gives us x squared? Well, that's x times x. So you're going to put an x up top there. Then what you're going to do, the same as we did over here, is we multiply. So we do x times x plus 3. And what I get is I get this, x squared plus 3x, and you write that beneath. Okay. And then what did we do over here? Well, we subtracted this 2-digit number by this 2-digit number. We subtracted. So let's subtract. And this is where it gets a little tricky with the signs and stuff. If you're subtracting a negative, please remember to add, and so on. So x squared minus x squared is 0x squared. That's why it doesn't show up there. 0x squared we do not have to bother to write. 7 minus 3x is 4x. So that's why we write a 4x right there. Then, just like we did before, we have to finish off this cycle by bringing down the next number, or in this case, we bring down the next term to create another binomial. And that's one complete cycle of polynomial long division. Okay? Depending on how long your original polynomial is here, you may be doing this cycle 3, 4, 5 times, who knows, right? But, so now we start over. I'll use a little bit of a different color here. And so x times what gives me 4x now. Now I'm focusing on this one. So that is x times a positive 4. So you put plus 4 there. Now you take the 4, multiply it by x plus 3. You get 4x plus 12. And write it underneath there. And then, of course, after we've done the multiplication, now we subtract. 4x minus 4x is 0x. That's perfect. That's what we want. And 17 minus 12 is 5. So our answer is, this is called the quotient, the result when we divide. This is the remainder, 5, or exactly, it's x plus 4 plus 5 over x plus 3. 5 of these x plus 3 fractions. 5 over this. That's the actual answer. This is your quotient. This is your remainder. Okay, so that's long division. I know that's a bit of a quicker tour through that. Okay, but we're going to get some more practice here with this example right here. And just as we move through this, as I mentioned already, the 5 in this example is the quotient. So the result when you divide is the quotient. You may have a remainder like this down here, remainder. This in here is the dividend. This is the divisor. Okay, so you may hear those words when I teach or in the textbook or whatever, and that you know which is which now. Okay, the quotient is the result when you divide, and so on. Okay, so divisor, dividend, quotient, remainder, those are the things that you need to know kind of what they are. All right, let's do an example together from scratch now, and let's get some practice with our long division. Okay, and yes, there's going to be a shortcut to long division that I'm also going to teach you in this lesson, which is called synthetic division. That's a bit of a shortcut. It's not going to be as much writing. It's a bit of a shortcut. So I'll explain that too, and you're going to use that a lot. All right, but the long division goes like this. Now, one of the things that we need to make sure, which I haven't mentioned this yet, but when you write your dividend underneath here, this polynomial, it's very important that every term is represented. So what I mean is this. If I had something like x cubed plus 1, I couldn't just write x cubed plus 1 underneath the radical sign. Why? Because I need the cubed term. I also need the squared term, and then the x to the power of 1 term, and then the constant. I need all of those represented underneath the radical, or the divisor sign here. So how I would actually have to write this one would be like this. I'd have to write it x cubed plus 0x squared plus 0x plus 1. That's how I would have to write this in order for this long division process to work. Okay, so that's just an aside. That has nothing to do with this particular example, but you may run into that later, and I don't know if I'll get a chance to mention that later. Okay, so it would be kind of like this. Like if you had 1007 and you were dividing that by something, and someone came along and said, "Hey, these zeros mean nothing, right? So let's just change that to 17." That's the same, isn't it? Well, it's not, right? So that's, in essence, that's what we have to be careful we don't do by not filling in every single term appropriately. All right, so x times what will give me x cubed? X times x squared. Now, what I do, the book doesn't necessarily do it, but what I do is I kind of keep all of the like terms in columns here. So I write my x squared over the x squared in the polynomial. You don't have to do that. I like doing that. It keeps things in a better order, and I know when I'm done too. So if I put an x squared there, I multiply, that's going to give me x cubed plus 1x squared, or just x squared. So now that's the multiplying step, right? So now that I have this times this binomial, I've written the answer there, now I subtract. So x cubed minus x cubed is going to be 0x cubed. That's great, don't write anything. 7x squared minus a positive 1x squared, 6x squared. Okay? You good with that? You guys should be writing this example down. If you are, good. Yeah, just so you stay with me. Now, after we've done the subtraction, we drop the next term down. So now this becomes a 6x squared plus 14x. And then we start the cycle over again. That's one complete cycle. Okay? Now we start over again. I'll use a different color here. I'll use gray. So now I look at x times what will give me 6x squared, right? Or you could think of it 6x squared divided by x, right? Same thing. I like to think of multiplication instead of division, but you can think of it any way you want. So 6x squared divided by x would be what? 6x, right? So plus 6x is the next term that I put in my quotient. So after you place that, then you multiply. So 6x times x is 6x squared. That's great. 6x times 1 is 6x. You subtract. That's going to be 0x squared. 14 minus 6 is positive 8x. And I drop down the 8. That's cycle number 2. Okay. So I'm going to go one more time. I don't have anything more to drop down, so that means that's when I'm going to end. But I have to do this cycle one more time. So x times what gives me 8x? Well, that's plus 8. So 8x plus 8. And what we notice down here, this is excellent. When I do this subtraction, I get 0. I get exactly 0, correct? So that means a couple things. First of all, we have nothing more to drop down, so we're done. We're done. And also what this means is when we have a 0 as a remainder, that means that this quotient and this divisor, they are factors of this polynomial. That's really important. That's going to be important for us moving forward. So if you divide something like, let's say a simple example, 12 divided by 3, well, 3 times what gives me 12? Well, 4. If you do this process, you get a remainder of 0. 3 and 4 are factors of 12. That's what that means. Same thing when we're talking about polynomials. If you have a remainder other than 0, these two numbers are not factors. That's what that means. Okay? So in this case, 0, that's great. And I'm leading into the next lesson. We'll spend more time on that later with the factor theorem. Okay? So that's long division. Any questions about long division? All right. So you will get some more practice at that. This right here looks like the check. If you multiply the two factors together, you should get the exact same polynomial that you divided. All right. Okay. I tell you what, let's, where are we at for time? Okay, let's do one more example here, then I'll talk to you about synthetic division. Okay, so write this down as an example. Okay, so there's example 2. And here's an example where we have to fill in every missing term in the descending order of x. So in order to write this, we actually would have to, we'd have to write it like this. X squared plus 0x minus 1. So you have to make sure every term is accounted for, and then we'll divide that by x minus 1. Okay? Again, that's just in order for this long division process to work properly. We don't want to miss a term. Okay. So x times what is x squared? I'm going to put a 1x up there. X times x minus 1 is x squared minus x. Now I'm going to subtract x squared minus x squared. That's awesome. It's 0x squared, and here's why we have to include this 0x, because if we had a 1 minus x, I'd be in a little bit of trouble there. So 0x minus 1x is negative x. Drop down this, and that's my one complete cycle. I'm going to do one more. So x times what gives me negative x? Well, that's minus 1. X times, let me see, did I do that correctly? Oh, what did I miss? That's a plus, isn't it? 0 minus a negative 1. Oh, nobody stopped me. Boy, you would have earned some big brownie points there if you would have uncovered my mistake. Too bad, you get no credit. 0. I recognize my own mistake. So this is actually, remember, 0 minus negative 1. So that's actually plus 1x. So x times what gives me x? That's a plus 1. 1 times x is x. 1 times negative 1 is negative 1. Subtract, I get 0. So let's see if this makes sense. X minus 1 times x plus 1 should equal x squared minus 1. Is that true? That's a difference of squares, right? You shouldn't even have to multiply that out to see, hey, that's a difference of squares. That's exactly true. So here we have a 0. So that means that this and this are factors. And yeah, okay. So any questions about that example for long division? Okay, don't forget if you subtract by a negative. All right, let's move to synthetic division. Okay, so synthetic division, I'm going to just kind of walk you through from the very beginning. You can jot down as many of these notes as you want, but I'm just going to walk through them. Sorry that they're handwritten, but I think as I read them, you'll be able to understand. So, with synthetic division, the first rule that's very important, the very first rule is the one that I've already mentioned, that the polynomial must have every single term from the leading term all the way to the constant term represented. So again, you can jot this down if you want. Again, you don't have to. It's on the video if you want to watch that. I've already mentioned that. But for example, x cubed minus 8, if I was going to do this, show a division of x cubed minus 8 right here, I'd have to write this as x cubed plus 0x squared plus 0x minus 8. So you have to make sure that every term is accounted for. Same in long division as this new synthetic division that we're going to learn. So that's number one. Okay? The polynomial must be represent every term. 2, what we want to do is, with synthetic division, we don't have to write out the whole polynomial with all the variables. We just focus on the coefficients of the polynomial. And the binomial divisor, we use the constant term. Okay, so let me explain this a little bit. All right. So the format for the binomial term that we're going to divide by is going to be x minus a. This a is actually what we use in our synthetic division. So, for example, if we had x minus 2, see that's what we're dividing up here. This is going to be our example, x minus 2. Then a, where am I? A is 2 here. If I had x plus 7, a would be negative 7. If I had x plus 1, a is negative 1, so on. So it's pretty easy. If you have a 1 here on the x coefficient, you just change the sign and use this same number. Okay? So we're going to use the coefficients of the polynomial to be divided, and we're going to use the a value of the binomial that is the divisor. Okay, so I'm going to erase some of this so that this doesn't look too confusing, and we'll do it step by step here. Okay. So the first step is to draw an elongated L. So here's my elongated L. Whoops. That's a bit of a funny line there. It's kind of an upside down divided by sign maybe, if you want to think of it that way. I don't know. Okay, and here's what we do. On the top row inside this L, we place all of the coefficients of the polynomial to be divided. So if we go back up here, we're going to do this example, x cubed minus 8 divided by x minus 2, okay? And I have to write 1, 0, 0, and negative 8 in my synthetic division elongated L. So 1 for the x cubed, 0 for the x squared term, 0 for the x term, and negative 8 for the constant term. Okay? So just to be clear, I'll write what we're doing here. We're doing x cubed minus 8 divided by x minus 2. That's what we're actually doing with this example. All right, so you put the coefficients up there. Now, over here on the side, this is where you put a. This is where a goes. So a is going to be positive 2. All right? So coefficients along the top. Coefficients along the top. And this is the a value right here in your binomial divisor. Okay? I know, this is terribly exciting. I know, this is like, you're just all like waiting with bated breath to see how this is going to turn. I just know it. I know. Anyways, once you get the hang of it, it's going to be easy to do, and you're going to have to do this a few times. Okay, so here's what we do. The rules are kind of down here. I've just got them scribbled down here. Drop the first number down. That's the first number in the coefficient list. You drop it down and put it underneath the elongated L sign. Okay? That's going to be your coefficient, the first coefficient of the leading term of your quotient. Okay? It's always going to be the same. In all the examples that we did, that's what we noticed. The quotient always had the same coefficient as the divisor. So drop that down. Okay? So that comes down just right there. The second thing, multiply your a value times the number that you drop down here, or this number down here. So we're going to go 2 times 1. And you're going to put the answer right here in the next column. 2. No talking, please, boys, while we're doing this. Yeah, you need to focus 100% attention up here. You're not going to get it. Okay? So nice and quiet. What we do now is we subtract. No, because we've used a, we're going to add. This is the one difference from the long division. We're going to add now. Okay? And when we use a, that's the big advantage of using a. We switch the sign over here, you see, from the binomial, so we get to add here. So 0 plus 2 right here, add them, and you write down the answer here now. Okay, 0 plus 2. And that's like the first cycle. So that mimics the first cycle of long division. All right, the first cycle. Now we're going to do that again. We're going to start from the top. We're going to multiply. We've kind of dropped this, down here by adding. So multiply a times this number again. So that's going to be positive 4. And we're going to add the column. 0 plus 4 is 4. And then one more time. 2 times 4 is 8. Write it down there. And then add. Negative 8 plus 8 is 0. Okay? One thing I forgot to mention that I always do is I always put underneath the last term, I put a little box under here. Okay? I always do that because that helps me remember that this number in here is going to be the remainder. So this right here, these are the coefficients for the quotient. And this is the remainder. Okay, so I've written that down under here. The numbers under the L are the coefficients for the quotient. And that quotient is always 1 degree less than the original polynomial. And the number in the box is the remainder. So I've just kind of rewritten what we did over here. And so I will show you that these numbers listed here, the 1, 2, and the 4 that we got, are the coefficients for the quotient polynomial. This original polynomial was an x cubed, and so this is going to be x squared, one less. So we've got 1x squared plus 2x plus, should be a plus, plus 4. Okay? That's right? Yeah. Okay? So that gives you, that's how you can get your quotient. And trust me, this is going to be a lot quicker once you kind of get the hang of this than long division. It's going to be much, much quicker. Now, I understand you guys went through this example yesterday, right? Let's do it again. We'll go a little bit quicker this time, now that we've got some more practice with synthetic division. So what we want to do for this one here, and you can rewrite this again if you want, x cubed plus 2x squared minus 7x minus 2, all divided by x minus 2. So to set this up, we do the elongated L, and we're going to write down the coefficients in descending order up on top here. I'm going to put my little box underneath the last number to show that that's going to be my remainder. A is positive 2. A is positive 2. So let's go through this example. Drop the 1, multiply, put the answer there. Add, put the answer there. That's one cycle. Again, multiply the 2 times the 4 now. Put the answer there. Add, put the sum right there. Again, third time, 2 times 1 is 2. Put the answer there. Add, put your number there. That's going to be your remainder. Okay, now how do we interpret this? Well, we started off with a cubic function, so the solution or the quotient here to this is going to be 1x squared plus 4x plus 1 with a remainder of 0. And to be exact, really what this remainder theorem actually says in this lesson is the remainder is this number, whatever this is, as a fraction over your original divisor. So that's just plus 0, right? Okay, so the title of this lesson was Remainder Theorem. The remainder theorem basically says that when you divide two polynomials, you can identify the remainder by using this number right here as a fraction over your original divisor. And this is the pattern that always happens. If it's 0, that's great. There's going to be ramifications for that next lesson. But this is the remainder always. This is the quotient. This is the remainder. This is in your textbook here. The result of a division of a polynomial in x, that's p of x, by a binomial in the form of x minus a is p of x divided by x minus a equals the quotient, whatever that polynomial is, plus the remainder over x minus a. So the remainder as a fraction there. That's the remainder theorem. So we're going to divide, we're going to examine what the remainder is that way. Okay? And of course it gives you some more examples of long division, and I'm not sure if they talk about synthetic division here in this section right here. So yeah, I think that what they do is they don't use the actual a, and they still subtract, which I do that a little bit differently. I make sure we change this sign of a, and then we can add, and it gets you in a lot less trouble. It's the same thing, just a slight twist on it. Okay. So finally, the last thing I'll point out here, as part of the remainder theorem, okay, and maybe this is technically the remainder theorem here, that we can, there's a shortcut not only to division, but there's also a shortcut to finding the remainder. And this is the remainder theorem in its fullness now. This is what is going to be really useful for us, okay? If you take a in your divisor, and you plug it into the polynomial. So your polynomial is p of x. If you plug it into your polynomial, then the answer you get when you evaluate that will be the actual part of that remainder. So that'll be, like, for example, here's an example right here, example 4. Okay, I'll leave that remainder theorem up there if you want to copy some of that. But if you have a polynomial like this, p of x is x cubed minus 10x plus 6, and you're dividing it by x plus 4, you could do long division and look at what the remainder is, that number at the bottom, right? You could do synthetic division, look at what that last number is in the box. Or you could, there's a little bit of a shortcut here, and you could just plug in the a value, so in this case would be negative 4, into the polynomial, the original polynomial, and whatever number you get is going to be the number that you would get as the remainder, as the number at the bottom of long division or the number in the box. It's always going to be the same. So in this case right here, p of negative 4, you plug in negative 4, you evaluate, you get negative 18. So that's going to be the number right here. You see, they showed you the little synthetic division. That's going to be the number that you get there in synthetic division. All right. So if we use this now to go back and take a look at one of our examples. So now let's take a look at this. So a is positive 2. So what is p of 2? Well, that's going to be 2 cubed plus 2 times 2 squared minus 7 times 2 minus 2. I've just plugged 2 in for the x. So p of 2 is 8 plus 8 minus 14 minus 2. 8 plus 8 is 16. Negative 14 minus 2 is minus 16. So look at that. We get 0, and that's the exact number that we got in our synthetic division. So the remainder theorem, okay, we can find a remainder, and there's also a shortcut to finding the remainder using the a value from our divisor. And this is going to be very useful when we have to fully factor long polynomials. Okay? All right, so it's a bit of a longer lesson here today, maybe a bit dry, okay, not the most exciting math lesson in your life, but being able to divide polynomials, being able to fully factor a polynomial is what's going to be really important moving forward. Okay, so we'll just head back to the textbook here to show you the remainder theorem, okay, and I'll let you take a look at also the key ideas. So just examine those for a moment, and let me know if there's anything in there that you still don't understand that I can help you with. So here's the textbook questions here. You had a question about something? Okay, you had a question about 4a?
Oh, I see.
So it's just synthetic division question there? Okay.
And then for 5 you have to express the number.